Okay. Oh, shoot. You know what? I think instead of, crap, I stopped. That's okay. Okay. So let's look at this. I'm going to work. If you're still working on it, that's fine. And something kind of crazy happens too for this one. But let's find the vertex first. So -2, right? Because we go to the left 2 and then down 5. We know because it's turns down, this means it's a max, right? Because A is negative. Now the axis of symmetry here is going to be -2. X equals -2. You've got to write it as X equals -2 because it's a vertical line. The X-intercepts. So look, really, we have to just put all this equal to 0. So I'm going to write it like this just to keep it a little more orderly. All of this has to be equal to 0 to solve the intercept. So now add the 5 over. I get -x plus 2 squared equals +5. I've got to move the negative over to get rid of it. So I get x plus 2 squared equals -5. Then I take the square root of both sides. So we get the square root of x plus 2 squared equals plus or minus the square root of -5. That's a negative there. So I get x plus 2 equals plus or minus. Now it's negative. The square root of a negative is an I. So it's I square root of 5. Okay. What that tells me is we don't have x-intercepts here. And so I'll see that on the graph here in a minute. And I'm going to go just one more step. I'm going to move the 2 over. So because we have an imaginary, we don't have x-intercepts. Okay. We just don't have them. We'll see if that's true on the graph. I'll check it on the graph here in a minute. So let's do the y-intercept. We'll always have a y-intercept. So if I plug 0 into the equation, in there, -0 plus 2 squared minus 5. So we get negative on the outside, 2 squared minus 5. This would be -4 minus 5. So we get -9. So we get 0, -9 is the y-intercept. And let's graph. Let's graph what we have. Now we go to the left 2, down 5. Yeah, see, there's my vertex, and I know it's a maximum. So that means it's going to go down. It's never going to cross the x-axis, guys. Okay? It's never going to cross the x-axis, and that's fine. They might not cross the x-axis. Now, I know my y-intercept, though, is -9. So it's 5, 6, 7, 8, 9. So it goes down like that. Okay, and then, my axis of symmetry is right there. Okay? So now let's do the domain and range. Look, domain, all real number. Quadratics always go to the left, always go to the right. Okay? Range, though, is a little different. Range here goes forever down, but then it stops, right? It stops at this maximum of -2, -5. So it stops at -5. So it goes -infinity, and then boom, to -5. Bracket because we can equal it. Okay? So boom, we did it. Now it's kind of goofy because we didn't have x-intercepts. And you'll see if you're doing this equationally, the x-intercepts always wind up having an I value there. Okay, if there's not one. Let me put it that way. If there's not an x-intercept, it'll pop an I out, which sounds kind of funny, but that's just how it is. Let me make sure. Yep. Okay, cool. So this is called the standard form of the quadratic equation. Now let's go over one that you're probably more familiar with, or you should be more familiar with. And I'm not sure how your book calls it. Excuse me. Standard form, and then it doesn't give it a name. Yeah, I remember this book now, I'm not doing that. I'm going to call it the general form. Why not? The general form looks like this. ax squared plus bx plus c, right? This is the general form of the line. Now, it's still a quadratic. This thing still looks exactly like a quadratic, okay? It's either smiling or frowning. It's got a minimum or a maximum. That's the vertex. Yeah, it's just written differently. Equationally, it's written different. So we have to go about it a few different ways. And the first thing that's different is finding the vertex here, okay? The vertex, which is kind of goofy, but it's its own little equation. The x value of the vertex actually comes from the quadratic formula. And if you remember the quadratic formula, it was like x equals negative b plus or minus the square root, blah, 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 all over 2a, right? Well, the x value of the vertex comes from the very beginning of that formula. The very beginning of that formula states x equals negative b, right? Then it's plus or minus all this stuff, all over 2a, okay? So that's the x value. The y value for the vertex, you just plug this in. So it's f of negative b over 2a. So we're going to do a few examples where all we're going to find is the vertex, okay? I'll tell you that a right there is the same a as before. If it's positive, it means that vertex is a minimum. We're smiling, okay? If that a right there is negative, it means it's the vertex is a maximum. It's frowning. But for now, we're going to focus on finding the vertex in this form. So let me give you a few examples. Let's say we've got g of x. I'm making this up so we might get really crazy, weird answers, okay? G of x equals 2x squared plus 8x minus, let's say, 5. So I've got this quadratic. Oh, I can tell you that's positive. It's a positive a, so I know this is a smiling quadratic somewhere. But for now, I'm just going to ask you to find the vertex. Okay, find the vertex. And to do that, we've got to find the x value first. And the x value is negative b over 2a. Now, remember, this is our a value, this is our b value, and this is our c value, okay? So negative b over 2a, that's going to be negative 8, that's the b value, over 2 times 2, okay? The a value is 2. So we wind up with negative 8 over 4. So we wind up with negative 2, okay? That's our x value. Okay? So now to find the y value, look, we only have one part of this. To find the y value, we have to plug it back into the equation. So g of negative 2. So we'd have 2 times negative 2 squared plus 8 times negative 2 minus 5, right? So we get, now negative 2 squared is a 4. So we get 2 times 4 plus, well, 8 times negative 2, that's actually negative 16 minus 5. So 8 minus 16 minus 5. Now 8 minus 16 is negative 8. Minus 5, I think that's negative 13. Okay? Check me if I'm wrong, guys. If I made a goofy math mistake, please do not be afraid to chime in and say I made a goofy math mistake. So the vertex, look, this vertex in this form takes a little bit longer to solve for, right? When it was in the form over here, in what they call the standard form, it was really easy. It's just negative 2 minus 5, right? But when it's in this general form, it just takes a little more time. You got to find the x value and then plug it in to find the y value. So the vertex for this one is negative 2, negative 13, okay? So let me give you another one. I want you to try this. So I'm going to pause it again and try this one on your own and just find the vertex, okay? So h of x equals, let me steal one out of here. H of x equals negative 3x squared minus 6x minus 13. And all I want you to do is find the vertex. And I'm going to hit pause on this one. Actually, I'm going to give you 2 examples. I'll do that one, and let's do h of x and then g, let's say z of x is, let's say x squared minus 8x plus 16. So try those 2. I'm going to hit pause. Okay, let's do this. So the first one, I know the x value is going to be negative b over 2a. Well, it's negative 6. So if you want to write negative 6, you're more than welcome to, but realize it just changes it to positive. Over 2 times negative 3. Man, that's a lot of negatives going on. So we get positive 6 divided by negative 6. So this winds up being negative 1 for the x value. Now we got to plug it in to get the y value. So h of negative 1 would be negative 3 times negative 1 squared minus 6 times negative 1 minus 13. Now, negative 1 squared is just positive 1, so that's negative 3 plus 6, negative, and then minus 13. So this would be negative 10, right? So the vertex would be negative 1 is the x value, and negative 10 is the y value, okay? So then now let's do this bottom one, which is a little different. So the x value is negative b over 2 times a, so a is just 1 here. So we get positive 8 divided by 2, right? So we get a positive 4. We plug that in, so z of 4 squared minus 8 times 4 plus 16. So we get 16 minus 32 plus 16. Hey, this winds up being 0. So our vertex is actually 4, 0. So our vertex is actually on the x-axis here. Okay, kind of neat. Yeah, the vertex is on the x-axis. We'll graph some of these here in a minute. Okay. But any questions about how to find the vertex? So if it's in this general form, it takes a little bit more. It takes a little bit of an equation to get to the general form. Okay, and takes a little bit more time than that. Okay. Okay. So then let's look at. Let's do the same thing we were doing earlier, but now with this general form. Okay. So let's say we've got f of x equals, and we'll do one that kind of actually has a really nice outcome for everything for this first example, and then we'll do one that actually is just more difficult with the numbers. So let's say we've got f of x equals, let me get this in focus, x squared, say, minus 6x plus 8. Okay, x squared minus 6x plus 8. Yeah. And I'm going to ask you a lot of questions on this one, actually, just like before. So A, what's the vertex? Now, I'm going to leave more room for this one because it's not just easily seen as we're doing this. So I'm going to leave like half a page here. And then, you know, of course, the max min, we know this is going to be a minimum because the A value is positive, right? So I can tell you right away, this is a minimum. B, let's do the axis of symmetry. A, B, C. We're going to do the X-intercepts if there are any. Remember, there might not be, like that last example we did, A, B, C, D. I'll kind of get this kind of over here to give us a little more room. The Y-intercept, which is easy to find in this form. Y-intercept, A, B, C, D. I think E and F were domain and range. But I'm going to graph it first before I get there, okay? Let's graph this bad boy. Okay. I have no idea what it looks like, so I'm not going to put digits on there yet. So let's get back to what we were talking about just before. So the vertex, now again, we've got this general form. I've got to do the vertex where I've solved for x first, where it's negative b over 2a. That's the x value. So it's positive 6 over 2 times 1, right? 6 divided by 2. So the x value is going to be a positive 3. And then the y value, I got to plug it in. So plug in 3, and I get 3 squared minus 6 times 3 plus 8. So I get 9 minus 18 plus 8. So is that 17 minus 18? Is that negative 1? Okay. So I think I get negative 1 here. Looks right. 9 plus 8, 17. Yeah. So negative 1. So my vertex is going to be 3, negative 1. Kind of cool. Okay. And then axis of symmetry. Oh, again, it's just x equals 3, right? It's the x value. X equals 3. X-intercept. So I got to set this whole thing equal to 0. this is when you could solve this with a quadratic equation. You could solve, actually, I think this one solves by factoring. That's why I chose it. So let's solve this one by factoring. So we get x minus 4, x minus 2 equals 0, multiplies to give me 2, adds to give me a negative 6. So I set each one of those equal to 0. So x equals 4, and x equals 2. So I've got two x-intercepts this time, 4, 0, and 2, 0. So I've got a lot more coordinates going on here, right? 1, 2, 4 coordinates. So, or no, that's not a coordinate, that's a line. So y-intercept is really easy in this form. Because remember, you just set x equal to 0 when you find the y-intercept, and these first two terms go away. They're 0, right? 0 squared minus 6 times 0, that's just 0 and 0 plus 8. So f of 0 winds up being 8. It's always the constant, okay? So when you're in this form, the y-intercept always winds up being that constant. So for us, that's going to be 0, 8. Okay? So let's graph what we have. Okay, we've got 3. Actually, we're going to go up to 8 here. 1, 4, 5, 6, 7, 8. I know my y-intercept's there. My two x-intercepts are 1, 2, 3, 4, right there. And then my vertex is 3, negative 1. Over 3, down 1. So look, my graph looks something like that, okay? Looks something like that. Now domain, just like before, look, domain's always going to be all real numbers, okay? Range, though, this one is a minimum, so it's going to go down to a number and then go up forever. It goes down to negative 1 here, right? So it's going to be negative 1 to infinity. And that's it, okay? So this stuff is similar, right, as before. If it's a max or min is similar from before, it's A. You're going to have to solve the intercepts a little differently, and then solving the vertexes is a lot different for this form, okay? Questions? Comments, concerns? I'm going to give you another one. It's going to be a little more difficult, but I want you to try it, okay? A little more difficult. Hold on, let me get to it. I just saw it a second ago. Okay, yeah. Let's say we've got f of x equals negative x squared minus 2x plus 1. And I want you to do the same thing, okay? Vertex, find the vertex. If you want to find max or min, we kind of get that, right? That's going to be a little bit of room. Is it the find the axis of symmetry? A, B, C. And then I want you to find the x-intercepts. The y-intercepts. That one's going to be easy. So E, domain and range. And then we're going to graph it. I just don't know how much room I'm going to have on this one. So I'm going to pause it again. I want you to try that. Okay, let's start this one. So we've got negative b, so x equals negative b, so that's a positive 2. Negative b over 2 times negative 1, right? Because a is negative 1 here. So we'd have 2 divided by negative 2, so we actually get a negative 1. Negative b over 2a, yeah. And I've got to plug it in. So we get negative 1 squared minus 2 times negative 1 plus 1. So negative 1 squared is a positive 1, but there's a minus sign out front. So it's going to be minus 1 plus 2 plus 1. So it becomes 2. So the vertex for this one is going to be negative 1, 2. Okay. Now, I know this vertex is going to be a maximum, right? Because the a value is negative, so it's going to be a maximum. X is the symmetry, it's just x equals negative 1. Now let's find the intercept. So I'm going to take this negative x squared minus 2x plus 1, set it equal to 0, and solve. Now, if it's factorable, I need that x squared to be a positive. So I'm going to make everything negative here. I'm going to divide everything by -1. And I get x squared plus 2x minus 1 equals 0. This doesn't factor, okay? And if you tried to factor it like this, you're not doing it right, because the negative in front of the x squared, if you were like, well, -1 times -1 is positive 1, but adds a -2, that's true, but this x squared has to be positive, okay? And it wasn't. So for that to be true, you have to have the x squared by itself. So because this doesn't factor, I'm going to have to use the quadratic formula. So x equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. 2 times, which one am I doing here? Hold on. I'll do this one. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this a would be a positive 1. Positive 1, okay. So underneath the radical, I get 4 plus 4, right? Because you have 4, and the -4 times 1 times -1 is a positive 4, so you get 8. So you get x equals -2 plus or minus the square root of 8 all over positive 2. So you wind up with, we got to simplify this thing. So -2, 8 is 2 times 2 times 2, so we can take a 2 out. So -2 plus or minus 2 square root of 2 all over 2, a bunch of 2's. And then this simplifies because there's a 2 that can be divided into all 3 of these. So this winds up being -1 plus or minus the square root of 2. -2 divided by 2 is -1. 2 divided by 2 is 1. We just don't write it. So our x-intercepts actually have a radical in them. Ugh, that's not good. -1 plus the square root of 2, 0. -1 minus the square root of 2, 0. We're going to have to get in the calculator and just get an estimate here to graph them. Okay, so let's do the y-intercept again. That's the easy one. If I plug x equals 0 in, it's always the constant. So for this one, it's just 0, 1. The constant's 1 up here. Okay, let's graph it. You know what? I'm going to have to use another piece of paper probably to do this. Actually, I'm going to graph it kind of small right here. It's what? -1, positive 2. That's my vertex. I know it's coming down. I'm going to take my calculator out and find out these two just with a decimal, just to graph them. So -1 plus the square root of 2. In my calculator, that's like 0.4-ish, positive 0.4-ish. So about right there. And then -1 minus the square root of 2 is like -2.4. So about right there. Okay. The y-intercept is 0, 1. It's right there. This all kind of goes together. And it looks something like that. Okay. It looks something like that. So the domain, again, is just all real numbers. The range, though, it goes forever down. But then it stops up here at this maximum at positive 2. Okay. It stops at that positive 2. And that's it. Now look, so for this one, the tough part was the x-intercepts, right? I mean, that took a lot of time. You got to remember how to solve a quadratic. I don't mind if you want to have some solving quadratic software in your calculator. Doesn't bother me at all. You just have to you have to know how to do it, okay? But solve the quadratic, find the vertex. Those two things took a little longer. And this form is just like that. It just makes it where it takes a little bit longer to solve these because of the form. Okay, are there any questions? I'm going to give homework here. It's a good stopping point. Okay, so for homework, it's on page 343, section 3.1. Starts on number 1. And I want you to do 1 through, I'm putting in some real world examples here. So I want you to try them, attempt them, I should say. And let's do 1 through 59 odd. 1 through 59 odd. Okay, on page 343. 1 through 59 on page 343. Any questions? I'm gonna switch over. I've got one more bit of housekeeping I want to go over, and it's because of Blackboard. As you guys know, my little arch nemesis this semester. But in Blackboard, I believe it shows an attendance grade. There is no attendance grade for this semester. Okay, you need to take that out if you're trying to calculate your grade. You need to just take that out. Okay, excuse me. Your grade for this semester is only based on the test grades. So I don't know why that attendance grade is in there. I did not ask for it to be in there, and I apologize for it being in there. I'm trying to get it taken out so it doesn't skew your grade. So realize your grade, if you're looking at some sort of like overall grade, it might look skewed right now because of that. It is in other classes. Okay, yeah, and I'm sorry, I don't know why it's in there. But if you go to the syllabi, the test grades are the only grades for this class. Now I'll tell you, as we go, we still have a lot of time. If you feel like you are just not, your grade isn't where you want it to be, there's still a lot of time to bring it up. I believe we have 3 more regular tests, and the final, I'll tell you this semester more than any, I'll take that final grade into consideration because it is cumulative. So if you're close, I'll take that final grade more into consideration once we get there. But just because this is the semester of forgiveness, okay? So are there any questions about the class? I want you to look at number 4 on the test. So go and look at it and then let me know if if it counted you wrong, and it should not have been wrong. Why is my hat tilted? Okay. Guys, I'm going to stick around for 10 more minutes. You're more than welcome to stick around and ask me any questions. I'm going to just hang out here. You're more than welcome to leave. Doesn't matter either. Either one is fine. Okay. I'm going to stop the recording now.